Thank you. Um, I love MTech. I tend to like going to conferences. We're going to hang out and learn something interesting. So that's one of the reasons I always look forward to coming here. As we're preparing for this presentation, I spent some time thinking about what I thought might be most useful to all of you for me to say today. And what I thought I'd do is say a little bit about trends in AI, why it's taking off, and then share a bit about how AI might affect your businesses, and then close off with some advice for how you can build your businesses in the context of this rising category of technology. So some of you might have heard me say before this phrase that AI is the new electricity. And what I mean by that is about 100 years ago, we didn't have widespread access to electricity here in the United States, but with the rise of electricity, that transformed every major industry. Agriculture was transformed through the rise of refrigeration, communications was transformed through the telegraph, manufacturing was transformed through the electric motor, healthcare was transformed. But today, all of these industries, you have a hard time imagining how to run these things without electricity. I think that AI technology, especially deep learning, as Mo was saying, has now advanced to the point where we see a surprisingly clear path for it to also transform every major industry. Now, despite all the hype about AI, and there is a lot of hype, it turns out that 99% of the economic value created by AI today is through one type of AI, which is learning A to B, or input to output mappings. For example, AI is getting really good at inputting a picture and outputting, is it you? 0 or 1. And this is why we're starting to have cell phones and other devices, and overseas even doors that unlock just using your face. Something I used to work on, AI that inputs a loan application, that's A, and outputs, will the applicant repay the loan? And it turns out, if you can figure this out, this is a decent business in terms of figuring out whether or not to approve someone's loan application. Possibly the most lucrative application of this today is online advertising. If you look at all the large online web serving platforms, the Google, Facebook, Baidu, Twitter, and so on, almost all the large ad platforms have a piece of AI technology that takes this input and ad and some information about you, about the user, and tries to output, will you click? Will the user click on this ad? Because for the online advertising platforms, every click is money, and so there is a very large incentive to try to show you an ad that you have a 5% chance of clicking on, rather than only a 4.5% chance. So maybe, I don't know, maybe not the most inspiring, but certainly an extremely lucrative application of AI. Let's see, speech recognition has been working really well. Both Google and Baidu have said publicly that over 10% of the searches on mobile devices now come through voice search, so there's large volume revenue. And the reason users are willing to accept voice input is because speech recognition is finally accurate enough for you to speak to your cell phone and have it transcribe that pretty accurately. So that's enabled by a form of AI that inputs an audio clip and outputs a text transcript. Machine translation, input an English sentence, output a French sentence, and self-driving cars. I guess I recently joined the board of self-driving car company Drive.ai, and a key component of every self-driving car, every modern self-driving car, is to input some information about what's around you, like a picture taken of what's in front of your car, and maybe radar readings or LiDAR readings, and output positions of other cars. Right, and so this is, with this learning A to B mappings, and a technical term for this is supervised learning. When this idea of learning A to B mappings is fit into the appropriate business context, this turns out to be incredibly valuable. Now, one question that I've often been asked is, what can AI really do? You read about so much exciting things in the news media. There's one rule of thumb that I've given to a lot of product managers I think has been helpful, which is, anything a typical person can do, with less than a second of thinking, we can probably now or soon automate. Actually, let me just. So if you look at a lot of the examples I had on the previous list, many of them, such as look at the picture and figure out is this a picture of you, many of those are tasks that a human can do in less than 1 second. And this is an imperfect rule, but this does not perfectly cover by any means. Both has both false positive and false negative. This is not a perfect rule. But this is an example of a rule that I've given to product managers before in large organizations, and this results in product managers running around trying to find things that they could do in less than a second to automate. And that was actually pretty valuable. Now, and of course, this is also a far cry from the evil killer robots, right? Now, one impact of this on the nature of jobs, I know MTech has spent a lot of time looking at the future of work as well, is that turns out there are a lot of people whose jobs are a sequence of 1 second tasks strung together. For example, a security guard watching a security video. Well, what is their job? They look at the video, figure out where the people, that's a 1 second task. Figure out where the people standing, that takes a second. Figure out where the heads, the faces of these people, that's a second. Figure out if any of these people that you see are a known bad guy, like a known shoplifter. That's another second. And so there are jobs that are at significant risk of automation because these jobs are a sequence of 1 second tasks that we string together. And so I think to the extent that those of us in tech are causing some of these job displacement problems, I think we have a responsibility to help address these issues as well. And can talk more about that later if you're interested. Now, Will mentioned the rise of deep learning, the rise of neural networks driving a lot of the recent excitement in AI. So the basic ideas of deep learning have been around for many decades, have been taking off only fairly recently. So why is that? If you remember maybe just one thing from this talk, if you remember just 2 things from this talk, remember this picture. If you remember just one thing, I think there's something else I'll say later. But why are neural networks and deep learning taking off just now? This is a picture that might try to explain it, which is if on the x-axis I plot the amount of data you have for a task, and on the y-axis I plot the performance, then what happened with the digitization of society over the last 20 years is for many vertical industries, we start to collect more and more data. And because our smartphones, computers, digital activities generate data, and also your health record is more likely 10 years ago would have been a physical piece of X-ray film. Today, it's more likely with digital image. The state of supply chains used to be pieces of paper in filing cabinets all over the globe. That's now much more likely to be stored in a computer. So the digitization of society has caused us to move to the right on this axis on a lot of industries. But what happened was for the traditional AI algorithms, really traditional learning algorithms, and for those of you that are technical, I mean things like support vector machines, logistic regression, the more traditional AI algorithms perform like that. It was as if even as you feed it more data, it didn't know what to do with all the data we now have. And what happened starting maybe 3-4 years ago was we found that if you train a small neural net, I'm going to use NN to abbreviate neural network, its performance looks like that. If you train a medium-sized neural net, its performance looks even better. And if you train a very large neural net, its performance kind of seems to keep going up. And so this means 2 things. First, this means that if you want the best levels of performance, you want to hit that level of performance, it means 2 things. First, it really helps if you have a lot of data, if you're far to the right of this axis. And second, really helps if you're able to train a very large neural network. So there has been a lot of algorithmic innovation. In fact, you hear from, actually, I think Ian Goodfellow later, one of the TR35 awardees, that's been driving some of the algorithmic innovation as well. But just being able to having computers fast enough, the rise of GPU computing to train very large neural networks, as well as the availability of huge data sets, I think have been 2 of the biggest drivers of this recent rise in deep learning. Now, it turns out there are also a lot of different algorithms being explored. And I wanted to share with you my own perspective in terms of what's really most valuable today, right? So I talked about supervised learning, which is learning this A to B mapping. And it turns out, some of these will just be buzzwords, but don't worry if they don't it turns out there are other types of machine learning you hear about in the news. For example, transfer learning is you learn from one problem, such as learn to recognize cats and dogs and people and pedestrians, normal terrestrial objects, and then use what you've learned there to try to read X-ray radiology images, because you have a lot of data of cats and dogs and people and pedestrians, but much less data of X-ray radiology images. So that's called transfer learning. Unsupervised learning. When I was leading the Google Brain project many years ago, we had a AI watch YouTube, and it figured out by itself that there were cats. It figured out the concept of a cat by itself. But learning to figure things out by itself without needing a lot of labeled data. And then there's also reinforcement learning, which is what was used in part for AlphaGo as well as playing video games. It turns out that if you look at what's actually driving economic value today, there's a rapid fall off as you go down this list in terms of the economic value created today. It turns out, for example, I think reinforcement learning is one class of technology where the PR excitement is vastly disproportional relative to the actual deployments today. Turns out that supervised learning has a huge hunger for data. Reinforcement learning has an even greater hunger for data. So it turns out to be great for playing video games, because if you're playing video games, you can play an infinite number of video games on the computer. Or for certain robotics applications, this works very well as well, because you can build a simulator for a robot and basically have a robot play a video game of itself. But outside of that, I think it's still a ways away from large-scale deployment, from widespread deployments. Having said that, one of the great things about tech is to draw this list today, and 2 years from now, with advances in research, maybe the ordering of this will totally change. But this is how I interpret the literature today. Now, the Achilles heel, of course, of supervised learning, right, is that it requires a lot of data. In particular, supervised learning requires a lot of data with both the input A and the output B. So for speech recognition, A was the audio clip and B was the text transcript. So today, leading speech recognition systems are built using north of 50,000 hours. There's about 5 years of audio data, which is a very expensive and very difficult asset to collect. Whereas you have 50,000 hours of data together with transcripts for all 5 years of continuous audio, all 50,000 hours of data. Despite that, so what we're seeing with the rise of AI era is a shift in corporate strategy as well, where it turns out that today, algorithms, AI algorithms, from a company point of view, are for the most part not defensible. There's so much open source, word gets out quite quickly. It's not that hard for most organizations to figure out what algorithms other organizations are doing. Maybe as a concrete example, so, I've had the privilege of leading AI groups at both Google and Baidu. And so today I have a pretty good sense of how web search technology works. But the leading web search companies have a data asset that tells them that if you search for United, if you do so in the United States, you probably want United Airlines. If you are doing this from the UK, I guess Elizabeth from the UK, you more likely want Manchester United, right, the football team. So that data asset allows the leading web search engines, Google, Baidu, Yandex, Bing, and so on, to provide to you much more relevant results, because there's a long tail in terms of what users search for. So even though today I have a pretty good sense of how web search technology works, I honestly have no idea how to build a small team to build a competitive, like a merely decent web search engine without access to that data asset. So this is one example of where that data asset, even more than the specific algorithms are, I think, makes the web search business incredibly defensible. Having said that, there is also maybe a little bit of excessive PR about the importance of data, because for new vertical categories, for new applications, maybe a new product idea that you have, it is often possible for you to get started even with a modest amount of data. So when I plan out and launch new products, I often plan out this type of virtuous circle. So you often see, if you're launching a new product, get a little bit of data that allows you to launch a product. Having a product allows you to acquire some users. Having users increases the amount of data you have, and this results in a positive feedback loop, so that after a period of time, you might have enough data to yourself have a defensible business. So maybe one concrete example. Some Stanford students I knew recently sold a company called Blue River to John Deere for about $300 million. So I knew them when they were Stanford students. They were actually taking my class when they were Stanford students. And so they have built these big rigs that go up and down fields, agricultural fields, and takes pictures of lettuce and makes life and death decisions about which head of lettuce shall live and which head of lettuce shall die. So when they were students at Stanford, I saw them. They were going out to these fields and using their cameras and just taking a bunch of pictures of these heads of lettuce in the field. And this allowed them to build a data asset that was not huge, but they took enough pictures to build a product that was good enough for farmers to start to accept it. And then they started rolling these things up and down fields, taking pictures of all these fields of cabbage and getting more data and having more users, allow them to have more data, and so on. And I haven't spoken to them recently, but after they're having done this for a few years, I would not be surprised if today they have the biggest data asset in the world of pictures of heads of lettuce kind of half buried in the dirt. And this actually makes their business, in my opinion, pretty defensible, because even the giant tech companies, the global giant tech companies, as far as I know, do not have this particular data asset. So, and this actually makes their business difficult, even for the very large tech companies to at least challenging for them to enter. So this is one example. The data accumulation is one example of how I think corporate strategy is changing in the AI era and in the deep learning era. Now, the last thing I want to share with you is this. All right, if you remember just one thing from this talk, maybe this is the thing I hope you remember, which is that there was a lesson I learned, studying or looking at the rise of the internet, that I want to share that lesson with you because I think it'll be useful for many of you as your organizations navigate the rise of AI as well. One of the lessons I learned with the rise of the internet era was if you take your favorite shopping mall. Actually, think of your favorite shopping mall, right? I live in Palo Alto. I live near Palo Alto. My wife likes Stanford Shopping Center, right? But think of your favorite shopping mall. Yeah, when I was a student at MIT, we used to drive north to the cheap outlet malls, right? Favorite shopping mall. Let's say we build a website for your favorite shopping mall, and let's say the shopping mall even starts to sell stuff on the website, right? That does not turn the shopping mall into an internet company. Right? So what defines an internet company if it's not whether or not you have a website that sells stuff? About 5 years ago, I was talking to I was talking to one of the CEOs of the large retailers in the US, and about 5 years ago, his CIO was saying to him, "Look, we have a website and we sell stuff on the website. Amazon has a website. Amazon sells stuff on the website. It's the same thing." But of course, it's not the same thing, and today they're definitely struggling with the onslaught from Amazon. So what is it that defines whether or not you're truly an internet company like Amazon versus a retailer that just happens to have a website? To me, what defines an internet company is whether or not you have architected your organization to leverage internet capabilities, to do the things the internet lets you do really well. For example, internet companies engage in pervasive A/B testing because you can on the internet, and if you don't, your competitors will, and they'll learn faster than you. Internet companies tend to have very short cycle times, right? We are used to shipping a product every day, or maybe shipping a product every week because we can on the internet, whereas a traditional retailer, might redesign their stores every 6 months. And so internet companies push and have to push decision-making down from the CEO to the engineers and the product managers, because the internet products and users is so complicated. A lot of the knowledge about what needs to be done lives only in the heads of the engineers and product managers. And so, in a traditional retailer, maybe a CEO can make all the decisions, and then everyone just does what the CEO says. But internet companies, only the engineers and the product managers know a lot of the best decisions. You have to push decision-making power down to them. I've been actually heavily influenced by some of Jeff Bezos' thinking, speaking on some of these. But to me, these are the things that truly define an internet company, not whether or not you run a website. So this was with what happened with the rise of the internet era. How about the rise of the AI era? Right? I think that if you take a traditional tech company and add a bunch of neural networks to it, but add a bunch of deep learning or machine learning or neural networks to it, that does not make it an AI company, right? And I think that today, no one has fully figured out what it means to be a truly AI company. I am biased because I worked at Google and Baidu. I think Google and Baidu are truly phenomenal and among the foremost thought leaders in figuring out what it really means to be a truly AI company. I don't think any of us fully know what this is yet. Just as maybe 20 years ago, we didn't really know 20 years ago that A/B testing was going to be such a big thing. I think we're still figuring out one of these things. But these are some things that I think might turn out to be true. One is strategic data acquisition. Right. For example, I drew that positive feedback loop. When I decide whether or not to launch a project, one of the criteria I use is, can we plan a path for data acquisition that results in the defensible business? And so, and maybe another example, I've done things like launch a product on a geography. In China, different regions speak slightly different regional dialects. So I've done things like launch a product in one geography, use that to get data to attack the neighboring geography, use that to get data to attack neighboring geography. But we don't make money from any of this. We take all this data and monetize it somewhere totally different. And so the leading AI organizations are starting to think through these, frankly, sort of multi-year chess games to acquire the data asset that allows you to build a defensible business. And this data acquisition strategy is really complicated. Here's one you can go home and implement. AI organizations tend to build unified data warehouses. And if you're a big company and you have 50 databases, under the control of 50 different vice presidents, then it'll be impossible if an engineer needs to combine data from multiple data silos to create value, and if they need to get approval from 50 different vice presidents, it's just not going to happen, right? So, for example, I don't know. Bunch of you traveled to Boston today. Based on your web search, we know what type of food you like, and based on your GPS, we know you're in Boston. Well, that could be put together to recommend a new restaurant to you for tonight. So the only way for those things to happen, either for the engineer or for the software to look at the data, is if it's in a unified data warehouse, which significantly increases the odds of your teams being able to connect the dots. So this is one, and this is often a multi-year exercise for companies to implement. And then I think internet companies tend to be very good at spotting pervasive automation opportunities and also new job descriptions, right? I feel like our traditional job descriptions for how we build teams and have them work together are breaking down a little bit. And maybe I'll just give one example of job descriptions that I think are changing. So in the internet era, we have product managers, right? That if you are designing a new web app or a mobile app, a standard part of the workflow for designing, say a mobile app, is for them to draw a wireframe, right? And a wireframe is basically a picture showing you, to tell the engineer what the app should look like. So I don't know, for the Facebook app, maybe there's a logo at the top, put your friends' faces there, right? Have a news feed there. and 5 buttons at the bottom. So product manager might draw a wireframe and give this to an engineer and say, please implement this. And this is part of the workflow we've figured out in tech, in Silicon Valley or in the tech world, in order to have product managers and engineers work together. But this is breaking down. But these old workflows and processes are breaking down in the AI era. So for example, if you're trying to build a chatbot, if a product manager draws, I don't know, this picture, right? So actually, one of the companies I've been helping out with is a chatbot, cognitive behavioral therapy chatbot. Right? Mental health is a significant problem in the United States, and you build a chatbot called Wobot, I guess in our case, to help out. So the product manager draws a wireframe. It says, chatbot says hi. If the user says, oh, I'm sad, then the chatbot says this. If a product manager gives this picture to a natural language processing engineer, the AI engineer or natural language processing engineer will say, this is totally useless. I don't need to know what the shape of the speech bubbles is. I need to know what's the substance of the conversation my chatbot is supposed to have with the user. Or to take a more extreme example, right? Been helping out with an autonomous driving company, Drive.ai. If a product manager draws this picture, right, and gives this to an engineer and says, hey, build this, right? The engineer says, that's totally useless. Why are you drawing me a picture of a self-driving car? So we're training product managers to use a new language to speak to engineers to give product specifications. For example, our product managers now know to create a data set and provide that to an engineer and say, dear engineer, are you able to deliver 98% accuracy on this data set at detecting cars between 50 and 100 meters distance. So we're having new workflows and processes for engineers and product managers to work together. All right, I think I'm running out of time. Let me just do one last thing real quick, and then we'll go to the Q&A. With the rise of AI, how do you incorporate AI into your company? This is a recommendation I've been giving to CEOs, more of CEOs of large companies. So most companies are organized as follows, where you have CEO and maybe multiple business units report to the CEO. Right? BU is my abbreviation for business unit. What I've been recommending to most companies to leverage these AI capabilities, which will probably transform your industry, is to build a centralized AI team and then to matrix in the AI talent into your various different business units. So why do I recommend this? Let's take an example. Let's say this BU, this business unit, is your gift card division, right? Your head of gift card might be a great leader, but there's a good chance that they don't have the capability to select and retain the top AI talent. And why would the top AI people want to work for your gift card division? So I think that if you can build a centralized AI team, this gives your organization more consistent hiring and promotion and HR practices in the AI era. And by matrixing the AI teams into the various business units, you can have AI people sit next to your gift card division and figure out how AI can help your gift card design or sales and so on. We've seen this pattern before with the rise of mobile. Maybe around 2011, none of us could hire enough mobile engineers, and we didn't really know what we're doing. We didn't know GPS would be such a big thing for mobile. What happened for a few companies, actually including Baidu, was companies built a centralized mobile unit, matrix in talent, but now every, MIT and Stanford CS undergrad graduates knowing how to program for iOS and Android. So now what's changed is that your gift card division unit probably can hire mobile talent. And so many of these central units have disbanded because it's now more efficient for the distributed organizations to just hire in their own talent. And if AI ever matures, then maybe AI will get there as well. But AI doesn't look as mature anytime soon. So I think at least in the current era, with very scarce AI talent, where we really don't know what we're doing, frankly, in AI, having a common team to have common standards, as well as build company-wide platforms that are useful for many business units, I think is an org structure that I'm seeing that I've been recommending to companies I think could help you build AI into your organizations. And this AI unit can also, with the rise of digital content, such as Coursera and many others, we now have tools for your chief learning officer or your central AI unit to provide very broad-based employee training to just level up your whole organization to better understand how to incorporate these AI processes in the businesses. I hope that was helpful. I'm definitely running over time. But let me say thank you very much.
And you have a seat.